today's lesson, and in our lesson today we are going to look at a question in physics which is coming from kinematics. And the question reads, a car starts from rest and is accelerated uniformly at a rate of 2 meters per second squared for 6 seconds. It then maintains a constant speed for half a minute. The brakes are then applied and the vehicle uniformly retards to rest in 5 seconds. So the question says, find the maximum speed reached in kilometer per hour and the total distance covered in meters. So the first thing that we're supposed to do there is to find the maximum speed reached. So how do we do that? We can be able to organize the data first of all. Okay, so if you look at this, definitely we'll have to find the maximum speed, which is the maximum velocity in this case. Okay, if you look at the information that we have our initial velocity, which is 0 meters per second. Why 0 meters per second? We are told that this one is starting from what? From rest. Okay. Then we have the acceleration there, which is the rate of change of velocity, which is 2 meters per second squared. Then we also have the time, okay, which is 6 seconds. So therefore, we are going to say that the maximum speed will be equal to initial velocity plus acceleration multiplied by time. So as we can see there, our initial velocity is 0 meters per second plus our acceleration, that is 2 meters per second squared, multiplied by the time, which is 6 seconds. So 0 meters per second, when you multiply 2 multiplied by the 6 there, it's going to give us 12 meters per second. If you add the 2, we shall say maximum speed is equal to 12 meters per second. Now, the question is telling us that the answer should be in kilometer per hour. That means we are supposed to convert, okay, the 12 meters per second, okay, to kilometer per what? Per hour. So the easiest way to convert this, take note that 1 meter per second is equivalent to 3.6 kilometer per hour. Okay, so if you want to convert a 12 meter per second, it will be equal to x. You cross multiply, you're going to have x meters per second being equal to 12 multiplied by 3.6 kilometer per hour. That will be 12 meter per second multiplied by 3.6 kilometer per hour. Okay, you divide both sides by the meter per second. Okay, meter per second. So what happens there is that this and that they will cancel. This and that they will cancel. We're going to say x now will be equal to the 12 multiplied by the 3.6 kilometer per hour, and that is going to give us 43.2 kilometer per hour. So therefore we can say the maximum speed reached okay, is 43.2 kilometer per hour. So we have solved one part of this question. Okay, now we look at the distance covered in meters. So in the first 6 seconds, okay, this vehicle was accelerating and it attained to a maximum speed of 12 meters per second. Okay, 12 meters per second. So we can be able to sketch the graph, okay, to help us understand this and find the distance. Okay, so if you are sketching a graph, your graph should have a title. That is very important. It's supposed to have a title. Okay, so we are going to say velocity, okay, time graph. Okay, velocity time what? Time graph. Therefore, once you put this title, your sketch will need to have the y-axis. Okay, it will also need to have the x-axis. Okay, so this vehicle was starting from origin. Then we are told that it accelerates. So we define acceleration as the rate of change of velocity. So meaning the velocity was changing from 0 up to the maximum there of 12 meters per second. 12 meters per second. And that 12 meters per second, it was traveled in 6 seconds. So you put your 6 seconds there. So this vehicle was accelerating. Okay, so the question continues to say it then maintains a constant speed for half a minute. Half a minute, that is 30 seconds. So meaning this had to move for 30 seconds at this speed of 12 meters per second. Okay, to about somewhere here, meaning here it will be 36 seconds. Why 36 seconds? At 6 seconds it maintained with the same velocity, okay, for half a minute. So we're going to add the 30 to the 6. It's the one that's going to give us the 36 there. Then we continue. The question further says the brakes are applied and the vehicle uniformly retards, meaning there's a decrease now in the velocity, okay, to rest in 5 seconds. So meaning it retards like this 5 seconds. You're going to add 5 plus the 36 there. It's going to give us the 41 seconds. So here you are going to write time, okay, in what? In seconds. Then on the y-axis we're going to write velocity in meters per second, like that. So after you are done with a sketch, okay, after you're done with the sketch, we can now find the distance. So we are told now that distance under the graph, the distance under the graph is equivalent to area of the given figure. Okay, so this shape that we have there, it is known as a trapezium. Okay, so we shall say distance there is equal to half. Then we're going to have A plus B, then multiplied by height. So as you can see there, OA is telling us that the vehicle was accelerating. Okay, then AB, that was a constant speed or constant velocity. Then BC, there was a retardation there. So what we need to do is we need to identify which one is our height, which one is our the value of A, and which one is the value of B on this trapezium. So the height there, it is this one here, meaning on the vertical axis, which is the y-axis. So from origin there, which is rest, to 12, that is going to represent the height, which is 12. Then from A to B, it will represent the width, which is the value of A there. Okay, so this one, how is it found? Remember, we are at 36, minus B is at 36, then A is at 6, so 36 minus 6, that is going to give us a 30 as the value of A. Then the value of B, it is from O there to C. Okay, so that is a 41. So we say 41 there. So after you have identified, okay, all these values, you now have to substitute on the formula. Okay, we now have to substitute on the formula. So we shall say that distance is equal to half, okay, A plus B, then multiplied by height. So we shall say half there, A it is 30, then B it is 41, then the height there it is 12. So we shall say 1 over 2 multiplied by 71, then multiplied by 12. So 1 over 2 multiplied by 12 is going to give us a 6 there. And if you multiply 71 multiplied by 6, okay, you are going to have 426 meters. So therefore we can say the total distance, okay, the total distance covered, okay, by the vehicle is 426 meters. Okay, so that marks the end of today's lesson.